Hi guys, welcome to my channel. Today we are going to discuss about how to design sequential circuits in Verilog. HDL synthesizer recognizes certain idioms and turn them into specific sequential circuits. In Verilog, always statements are used to keep their old value until an event in the sensitivity list changes that explicitly cause them to change. So we'll be using always statement in Verilog here to design our sequential circuit. Okay, and we'll also check whether our synthesis is correct or not through RTL synthesis. So I have already designed this D flip-flop here. It will have inputs. Let's say my input is first 4-bit input D, and it will have enable input also. So I'll write that input clock, input enable, input reset for resetting the flip-flop, input D 4-bit, and output reg also 4-bit, so 320 Q. When we're writing a sequential circuit, it is mandatory to use the always statement, always at the rate. Now whatever you mention inside the brackets here is known as the sensitivity list. Let me mention positive edge clock and pos edge reset. So I have mentioned two statements here, pos edge clock and pos edge reset. So whenever my clock changes on rising edge, this always statement will change, and also on rising edge of reset, this always statement will be executed again. Otherwise, it will retain the old value in Q. And now we write the if statement here. If reset is on, I want my Q to be set as 4-bit 0. Okay. Else, if enable is on, Q should be set as equal to D. Okay. So basically all our conditions are completed now. If enable is not on, okay, Q will be holding that value and it will contain the last value. If reset is on, Q will be set to 4-bit 0, and this less than equal to is known as the non-blocking assignment. We'll proceed further now, and whatever that we have mentioned in the always block, it has to be declared reg. This is why the output is having a reg here. And we'll save this and check syntax if any errors are present. No syntax errors are present and also no warnings. We can proceed further with design of RTL schematic. Okay, our RTL schematic is ready. We have 4-bit D input, and input clock, enable and reset input also, and also output is 4-bit. We proceed further with development, and on double clicking we see that the fundamental unit of D flip-flop is used. D is connected directly to D, which is a 4-bit bus directly. Enable is connected to clock enable pin. Clock is connected to clock pin of positive edge trigger, and reset is connected to the clear input, and output is connected directly to the 4-bit bus. So this is how we design sequential logics in Verilog. If you have any doubt, let me know. Please let me know in the comment section. Thank you. In the next lecture, we'll be covering how to write test bench for this D flip. Thank you so much.